Data Assimilation Module. Introduction. To make forecasts, we need to know the past and the current state of the system, and need to understand the processes that govern the system changes. The Quantectum earthquake forecasts use a data assimilation module to estimate the initial conditions of the Earth's lithosphere for deriving the forecast models from the available seismological observations. The better the starting conditions are described, the better are the forecasts. This is the so-called initial value problem. The data assimilation module aims to provide forecasting models with the best starting values. Quantectum data assimilation module collects the following information from the publicly available data: active tectonic faults data, volcanic eruptions, past and current earthquakes. Active tectonic faults data are publicly provided by USGS and GEM, Global Active Faults Project. USGS only provides the low-resolution data on the major tectonic plate boundaries, where the global seismic activity has roughly the highest rate. The GEM, Global Active Faults Project, is a compilation of global datasets of active faults for seismic hazard assessment, as well as for research, education, and a general interest. While this is a work in progress, a lot of the world is already covered. Volcanic eruptions. The Quantectum also uses the Volcanoes of the World database by Smithsonian Institution, National Museum of Natural History, Global Volcanism Program. This is a catalogue of Holocene and Pleistocene volcanoes and eruptions from the past 10,000 years. However, Quantectum only uses the database of volcanic eruptions after the year 1976. Currently, there are more than 1,760 volcanic eruptions in our catalogue. Past and current earthquakes are publicly provided by several reliable providers, for example, EMSC, more than 870,000 events since 1998. IRIS, more than 6,200,000 events since 1960. CMT, more than 54,000 events since 1976. ISC, more than 7,400,000 events since 1900. USGS, more than 3,600,000 events since 1900. Historic mode. The collected earthquakes are directly uploaded into the Quantectum GIS system every 15 minutes through OBSPI and can be accessed on the Quantectum GIS system via historic mode. The main purpose of the historic mode is to provide our users with all relevant historic data at any point on the Earth. Earthquake catalogs can then be downloaded and imported into the T-Tecto Lite computer program to calculate the time synchronizations in the chosen region or along the chosen tectonic fault zone. Besides, these historic data are used by the Quantectum in the ensemble earthquake forecasting systems. Conclusions. Data assimilation is a technique that provides the Quantectum seismic models with the best starting values for every time they run. The earthquake forecasts created by Quantectum are 3D computer models of the lithosphere. Each of the simulated lithosphere models is described by a computer code based on the known laws of physics, stepping forward in time to move a virtual layer around the virtual globe, and predict future seismic states of the Earth's lithosphere.